All right, cool. Let's get started. So I just wanted to post a small video for your first CPR quiz with some answers. I won't go through it in the full answers because it is an NCEA question and the answers are online, but I just wanted to kind of walk through it just to show you how to process the question. So this first one here is from the 2021 exam, so last year's exam. In this example, they're talking about Rocket Lab, and they launched satellites into orbit using the Electron rocket. In the actual document, Google Doc, you'll have an image of it. But as I said with you guys at the start, they always give you these sort of tables, or they usually give you these sort of tables. And what's really key is that classification of that type of solid. Use that periodic table as a reference point to see what's metals and what's non-metals, because that'll help you make that decision. Oxygen is a non-metal. Copper is a metal. And then graphite is a non-metal. So from that, I can tell already that I don't have any ionic compounds in this question. This is a metal on its own, so since that's just a metal, I can tell very quickly that that's my metallic solid. And remember, with metallic solids, those are made up of atoms, and the attractive force is the metallic bond. Now, both of these are nonmetals, so that gives me the choice of either covalent network or covalent molecular, and I need to figure out which one's which. The thing to remember with this is if you are not sure, read the rest of the question to see if there's hints to help you. The other hint is that you should only have one of each type of solid. So pick one as your covalent molecular and pick the other as your covalent network. Let's read through it and see if there's any hints to help me figure out which one's which. So this one just says copper is used for electrical wiring. It's due to its ability to conduct electricity and stretch, and they want you to use your knowledge of structure and bonding, aka your knowledge of the particles and attractive forces. So you should be talking about both in that context. So explaining what metals look like, and then what is the bond that holds them together. And that's why this table is really important, because you're going to be referencing the things in that table. So nothing in there that helps me with the oxygen and the graphite question, so I'm going to keep reading. I see here that it says liquid oxygen is stored in an oxygen tank in the rocket. The tank is made up of a carbon composite material, which is made up of graphite. Under atmospheric pressure, oxygen turns into a liquid, from a liquid into a gas at negative 183 degrees Celsius, while graphite must be heated to around 1300 degrees Celsius to turn from a solid to a gas. Using your knowledge of structure and bonding, explain the large difference between these temperatures in each substances. So what I can see here is that this is a very low, that one's boiling point, whereas this one here is a very high boiling point. So remember how we were talking about covalent moleculars have really low boiling points. So that's how I can figure out that oxygen must be my covalent molecular. And then the graphite must be my covalent network. The other thing to kind of think about when you're looking at that is think logically. I mean, you guys, oxygen's in our air right now. We breathe it, so that's a gas at room temperature, so it must be the covalent molecular. For covalent molecular, don't forget the type of particle is molecules, and the attractive forces would be the intermolecular forces. They're very, very weak. Whereas with covalent networks, you also have atoms as the type of particle, but this is going to have the covalent bond. The thing that is important to remember about stating these attractive forces is that in these two answers, I'm not saying intramolecular forces, even though they are intramolecular forces. The reason why is because I want to be more specific. You can use intermolecular forces for the covalent molecular because that is the right specification for it. Cool. So that's kind of the setup of how to answer it. I'll just kind of show you the PDF as well with the answers. This is linked on my Google site, but I just want to show you how they broke down the points. I'm really actually quite surprised that they were so generous with the table, and that if you had the table filled in perfectly correctly, they would give you a merit point. I think they probably were that generous because of factoring in the lockdown. In fact, that there was so much remote learning last year that they made a more generous marking schedule. If you see this little slash here, it means they'll accept either answer. So with metallic solids, it's also okay if you want to describe them as nuclei with delocalized electrons, or cations, because cations and nuclei mean more or less the same thing, because you're talking about that positive charge being attracted to that negative charge. Cool. This here is the long kind of justification answer of what you're thinking about for justifying the properties of metals. The main thing with this types of solid question is that usually the way the points break down is an excellence level student can explain both of the properties. Merit level student might only be able to do one. But I would say this is a relatively easy excellence point if you know what you're doing. For the achieved is basically just stating what you know. So worst case scenario, just give definitions and descriptions. So just describe what metals look like. You can see here that they're being generous with the conductivity. They're just saying that you recognize that there's a free charge particle, but if you want to get the higher level points, you need to be more specific and state those valence electrons. And in this case, there was only 2 achieved points. With that or, whenever you see that, that means that they were going to only award 1 achieved point for either of those 2 description or identification statements. In part C, there was the oxygen and the graphite question. Again, you had an or option and identifying the forces. Similar breakdown with how the excellence and merit points were. Excellence points were if you were able to describe both substances, whereas the merit point was only if you were able to describe one of the substance. So like I said, this is a very generous marking schedule for that. And then the last thing to look at then would be the point breakdown. So in this case, there were 2 excellence points, and you needed to get both of those excellence points to get the E7 or the E8. So that's where they kind of made up for the fact that this is very easy. When you see minor error, it means that you've made a mistake somewhere. So for example, maybe your minor error is that you didn't specify that there are valence electrons and you just said charged particles. That would mark you down from an E8 to an E7. With the merits, there were 1, 2, 3, 4 merit points. So you got to get all 4 to get the M6. M5 was just getting 3 of them. And I would say for the achieved stuff, that is pretty generous. There's 1, 2, 3, 4, 5 possibilities. So they allowed you to miss 1 and you can still get an A4. What else did I want to say? Most likely, you would probably be getting an E7 instead of an M6, simply because the way the points are designed for the merit it's built into the excellence. So I'm not really sure how many M6s they might have handed out. I'm guessing they probably handed out the M6s when you had more than 1 minor error for your answers. But that is the marking schedule and the answers for the CPR quiz number 1.